Hi guys, this is Mrs. Scott. Today we're going to wrap up Chapter 2 with a Section 2.7 on prove angle pair relationships. So by the end of the lesson, we should be able to identify and say what are the relationships between different types of angles. Well, in order to prove things about angle pairs, we need to talk about some theorems, or in other words, rules that certain angles have. So the first step for today is we're going to fill in this table with some diagrams and statements about some theorems, or in other words, rules for certain types of angles. All right, so the first one is Theorem 2.3, which is the right angle congruence theorem. And what that says is all right angles are congruent. So if you have a right angle that's congruent to another right angle over here, no matter if it's in a different orientation, because we know that those are all 90 degrees. So they're all congruent. All right, the next theorem is the congruent supplements theorem. Okay, so this one says, say we've got this angle 1 here, and then we have this angle 2 here, and then over here, down here, we have angle 3. So this tells us, say that we know angle 1, so if angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. This might look familiar, but what happens then is that we can conclude, so the conclusion then, angle 1 is congruent to angle 3. Right? So if 1 and 2 are supplementary and 2 and 3 are supplementary, that means angle 1 and angle 3 have to be equal. Right? It kind of looks like the transitive property. All right, let's look at Theorem 2.5, the congruent complements theorem. All right, so this is actually very similar to the congruent supplements. So say we have this angle 1 here, and we have angle 2 here, and then over here we have angle 3. So that tells us if angle 1 and angle 2 are complementary, so they add up to 90 degrees, and angle 2 and 3 are complementary, then angle 1 has to be congruent to angle 3. Again, looks kind of like that transitive property, but if they're both congruent or complementary to 2, then 1 and 3 have to be congruent. All right, next theorem talks about the vertical angles congruence theorem. And we talked about this in Chapter 1, but it turns out that vertical angles are congruent. So vertical angles, remember, are when you have two lines that intersect. So let's say we have these, and we have angle 1, 2, 3, and 4. Well, angle 1 and 3 are congruent because they're vertical angles. Same with angle 2 and 4. All right, that's an important one. We'll use that one quite a bit this year. All right, and the last one is a postulate. The linear pair postulate states that, say we've got a linear pair here. So we've got angle 1 and 2 here form a linear pair. So if angle 1 and angle 2 form a linear pair, then angle 1 and angle 2 are supplementary. And we know that also by the definition of a linear pair, but there's a postulate for it as well. Okay, let's use that to make some sketches here. So we're going to make a sketch of the given information and label all angles which can be determined. All right, so example 1, we have congruent angles forming a linear pair. So we know we're going to have to make a line. The only way those two angles can be congruent is if they are both 90 degrees. All right, so they add up to 180 if they're both 90. All right, example 2, non-adjacent supplementary angles with one angle measuring 42 degrees. Well, let's start with this 42 degree angle. And they can't be touching, so over here I have to make an obtuse angle. So those would add up to 180. Well, then this would have to be 138 degrees. All right, so those are non-adjacent and they add up to 180. All right, the next picture is kind of a tough one. So we have angle ABC and angle CBD are a linear pair, and angles CBD and DBE are adjacent complementary angles. Let's start with the first statement. Let's start with that linear pair. Okay, so we can draw a linear pair. Notice point B is in the middle, so I'm going to put B in the middle. And then they share C, so I've got angle A, B, let's put C over here, and CB, this is going to have to be point D, are a linear pair. So we've got that. And this angle CBD and DB, we need to put a point E down here to make these two acute angles adjacent and complementary. Well, if they're complementary, that means this right here has to be a right angle. All right, so we got all of the information in this one diagram. And lastly, vertical angles which measure 125 degrees. So start by drawing two intersecting lines. And the obtuse vertical angles are 125 degrees. And we're supposed to label everything that we can. We can figure out these as well because 125 plus something has to be 180, meaning these vertical angles have to be 55 degrees. All right, so a little bit of drawing practice given a description. Okay, we're going to throw some algebra in here. So we are going to find the values of the variables in this figure to the right. I'm going to start with x. Notice we have an x here and an x here, and those are vertical angles, so they're congruent. That's that theorem 2.6 tells us that. Meaning we can say 7x equals 5x plus 18. All right, then let's go ahead and solve for x. So we'll subtract the x's, the 5x from both sides. So these cancel. We end up with 2x equals 18. And if we divide by 2, we can see that x is 9. All right, we can do a similar equation using the obtuse vertical angles. 13y has to equal 16y minus 27. All right, let's subtract the 16y over. We'll get all of our variables on the left. So these cancel. We end up with negative 3y is equal to negative 27. And if we divide by negative 3, we end up with y also equals 9 in this case. All right, and just this is actually a very unique case. For these types of problems, x and y are not necessarily the same. So this is just kind of a unique case. So don't let that make you think that anytime you do this type of problem, you're going to get x and y equal. That doesn't always happen. All right, to finish up this lesson, we're going to do a proof involving vertical angles. So they give us that angle 2, is congruent to angle 3. So let's put that in the picture, and then let's write that for our first statement. We always start with the given. And eventually we're going to, this is actually going to be a 5-step proof. We're going to get down here to step 5, concluding that angle 1 is congruent to angle 4. All right, well, first of all, there's a few vertical angles happening in this diagram here. I can say that angle 2 is congruent to angle 1. So let's start there. And why is that? Well, those are the vertical angles theorem from the previous page. And same over here. Let's see. Well, take a look at this. I've got that angle 2 is congruent to 3, and angle 2 is congruent to angle 1. So they share angle 2, meaning angle 1 has to be congruent to angle 3. Do you remember why? If they share something, then the other things are congruent? That's that transitive property. All right. I have one more pair of vertical angles that I haven't used yet, 3 and 4, so let's go with that. Angle 3 is congruent to angle 4. That's another pair of vertical angles. And lastly, if 1 is congruent to 3, 3 is congruent to 4, so we can cut out the middleman, see that they share angle 3. So 1 is congruent to 4 by, again, the transitive property. All right, so we proved that this angle 1 and 4 do have to be congruent. All right, thank you guys again for watching.